In this video, we are going to be looking at section 4.3 for Mathematics 058, and it's dealing with the topics of decimal numbers and percents. This percent symbol is a recent form to represent 1/100th when talking about percents in writing. The percent symbol slowly developed over several hundred years from its original form. Use the keywords percent symbol history to answer the following questions, and I've already done the research for us. When was the symbol first used? And from what I found, it was used by the mid-17th century. But before the symbol was created, the word that was used to write about percents was percento, which means per 100. And that was actually around the 15th century that was being used. You won't be expected to remember this, just maybe you'll see it one day on Jeopardy! So when you're writing a decimal number as a percent, you need to change the decimal to a percent by moving the decimal places 2 spaces to the right. Attach the percent sign and add zeros when necessary. So their example shows 0.25 is the same as 25%, and the decimal was moved 2 spaces to get afterwards. An example where you might need to add a zero would be if you have 0.4. Notice there's only one decimal number, and so in order to move 2 spaces, we would have to add a zero to accomplish that, because we have to fill a number there, so that would equal 40%. And notice the zero is put at the end and not before the numbers. Now you're going to do the opposite when writing a percent as a decimal number. So when you're writing a percent as a decimal number, you will take away the percent sign and then move the decimal 2 places to the left, and again adding zeros when necessary. And so for our 56%, notice they dropped the 56, or sorry, they dropped the percent and added the decimal where it would be in a whole number. It's at the end, and then moved it the 2 spaces to the left to make it 0.56. Now an example when you would need to add a zero is, let's say that we have 7%. So again, they want us to just look at the number, which is 7. The decimal would be at the ends. And so now, when we're moving our decimal 2 spaces, we're moving 2 spaces to the left. And notice this time, our 0 will go in front of the number instead of after. And so as a decimal, we have 0.07. Multiplying and dividing by powers of 10 and how those actions relate to the placement of the decimal point in a number was discussed in sections 3.3 and 3.4. Now those weren't sections that we covered in 058, and so if you didn't look at them already in 041, then you can go back in your workbook and look at them if you would like to review that information. But instead of moving the decimal point 2 spaces to the right, what is another way to write the rule for changing a decimal? So when we're moving the decimal 2 spaces to the right, remember it's getting bigger, and so we show getting bigger by multiplying. So that is the same as multiplying by 100. 10 would move 1 decimal place, so 20 moves 2 decimal place. And so for the decimal point moving to the left, we are getting smaller by 2 spaces, And to get smaller, it would be dividing. And again, dividing by 10 would move 1 decimal place. So dividing by 100 would move 2 decimal places. So money is useful for connecting the fraction, decimal, and percent forms of some common values, since it's something we're familiar with and we use often. So let's fill in this table with each form of our money coins in value. Our penny is already filled in for us. It takes 1 penny. It takes 100 pennies to make $1. So a penny is 1/100th of $1. And as a decimal, it's 0.01, and a percent is 1% of $1. Our nickel we know is 5 cents, so it's 5 cents where 100 cents make $1. Now it says unreduced fraction, but in most cases you're going to end up having to reduce your fraction, so let's go ahead and reduce it. And we have 1/20th when we reduce it, and that makes sense to me because it takes 20 nickels to make $1. And the decimal form of a nickel would be 5 cents of 0.05. And decimal place 2 spaces to the right to change our percent would be 5%. Our dime is 10 cents, and still 100 cents makes $1. Reduced fraction would be 1/10, and 10 dimes make $1. As a decimal, 10 cents would be 0.10 if we're looking at 10 out of 100, or 1/10. We could simplify it by dropping that 0 off and making it just 0.1. Either way is an acceptable way of writing that. And it is 10% of $1. Our quarter is 25 cents, where we still know 100 cents makes $1. And 4 quarters make $1. And so our reduced fraction form would be 1/4. And our decimal would be 0.25. If you like to put a 0 in front of it and make it 0.25 for any of your decimals, you can go ahead and put that 0 in front. And we have 25% if we move that decimal 2 spaces to the right. And then our $half is worth 50 cents, as we know, so 50 out of 100. Or as the name suggests, it is 1/2 as a reduced fraction. So just like our dime, we can write it as 0.50, or drop a 0 and make it 0.5. And that gives us 50% of $1. So let's think of our answers when looking at these true-false statements. And it says if it's false, we need to write it so that it is true. So for number 4, the coins listed in the table are worth less than 100% of $1. Well, 100% means the whole thing, so all of our coins listed are under $1. And so this is true. The coins listed in the table have a decimal form less than 0.01. Less than means smaller than, and so that's not true. It is false because we don't have any coins that are smaller than a penny. And so the coins listed above are in decimal form less than. We could say 1.00 for $1, or we could say instead of less than, we could say that it's greater than, or actually equal to, because the penny would be equal to it. So let's put that, greater than or equal to 0.01. And then a dollar coin is worth 100% of $1, yes, because even if it's a coin versus paper, $1 is still worth $1, and 100%, as we mentioned, is the entire thing. So here's some examples for you to work with. Change each fraction to a percent. And so notice your two fractions that you're given are out of 100, so you can look at just the numerator to get your percent, because percent means out of 100, so you would have 26% or 13.9%. But if you're given something other than a denominator of 100, such as 2/5, you need to divide to get your decimal, and then decimal to a percent. So divide, in this case, 2 by 5 to get 0.4, then multiply by 100, remove that decimal 2 spaces, so write to get 40, and now it's in percent form. So there's an example. Remember, decimal to a percent, you're moving decimal 2 places to the right, and percent to a decimal, the decimal 2 spaces to the left. And again, in either case, adding zeros when necessary. So finish these and check your answers, and then we'll move on to the story problems in just a second. Oh, I forgot about our chart here, so let's go ahead and look at this chart before we move on to our story problems, because you're going to be seeing a chart like this again. Hint, hint. And so we have our fraction column, decimal column, and percent column. And so we need to take one form and turn it into the other two forms. When we look at our decimal and we want to change it to a fraction, what we are going to do is we are going to look at the number that we see and not worrying about the decimal for a second. So we see the number 12. And then we're going to count how many digits are past the decimal. See how many zeros we put in the denominator. 12 has 1, 2 after the decimal in the decimal form, and so we need 2 zeros because that decimal place, we would read that as 12 hundredths, hence the 2 zeros, 100. And it's telling us to reduce our fractions, and they're both multiples of 4. You can use your calculator to simplify this, and that will give you 3 out of 25. So let's do that process again and skip ahead a little bit and look at 2.34 and change it into a fraction. So I see the digits 234, 234. So I'm going to write that in my numerator. And then again, I count only 1, 2 spaces after the decimal. And so I'm going to put 1, 2 zeros in my work. And then I'm going to simplify it. And if we simplify 234 over 100, we are going to get 117 over 50. Most likely your calculator, if you try and simplify that, will give you the mixed number version, which is 2 and 17/50. That is perfectly valid, but if you need to write it as an improper fraction, then if you use your second button and your fraction button with it, it'll switch from an improper fraction to a mixed number or back. So there's decimals to fractions. Decimals to percents we know are pretty easy because all we're doing is moving that decimal place 2 spaces to the right or multiplying by 100. So we're going to get 12% for our 0.12 and 234% when we move 2.34 2 spaces to the right to get 234. Okay. Now let's look at our fraction to decimal to percent, and we'll skip our percents to last. We have 1 and 9/16, and so what you're going to do for your decimal is you can either use the fraction decimal button on your calculator and it'll change everything for you, or know that your whole number goes in front of your decimal. And to get a fraction to a decimal, you're dividing numerator by denominator. So we would do 9 divided by 16 to get the decimal equivalent, which is 0.5625. So again, that 1 went in front of the decimal, and then 9 divided by 16 is 5625, so we have 1.5625. And now moving that decimal place 2 spaces to the right will give us 156.25%. Anytime you have a whole number, so something over 1, you will have more than 100%. And notice I did not round in either case. I left the decimal along and the percent with a decimal in it. So unless it tells you specifically to round and your answer doesn't go on forever, then you need to leave it the way it comes up. Now let's look at percent to decimal to fraction. And we're going to start with the 30% because it's easier. And so 30%, we know that that decimal would be at the end. So we need to go 2 spaces to the left to get our decimal equivalent, or 0.30, which we know we can drop that 0 and make it 0.3. And so if we're looking at the 0.30, we see 30, and there's 2 spaces after the decimal, so we would put 2 zeros, or we see 0.3, oop, took too much away, or we see that 3, and notice that one only has 1 digit after the decimal, so 1 0, so 30 over 100 simplifies down to 3/10. The most difficult one I think you'll find is this 3/8%. And the reason I'm saying that is because right now we have it in a fraction form, and we're used to changing percent to a decimal by moving that decimal place 2 spaces to the left. So let's do 3 divided by 8 to change it to a decimal, and we get 0.375. But that is not moving the decimal, that's just renaming it as a decimal, so that 0.375 is still in percent form. And so we would need to move that decimal 2 spaces to the left to get it into decimal form, which would give us 0.00375. And that is a common mistake, is to put that 0.375 in the decimal column instead of realizing that it's still a percent, that we haven't moved anything. And then if we follow what we've been doing, we see 375 in our decimal. But when we count the number of decimal places, we get 1, 2, 3, 4, 5. And so we need 1, 2, 3, 4, 5. So that's 100,000 now in our denominator, and it reduces down to not 3/8, because that was 3/8%, but 3 out of 800. So notice the difference. Remember, percent means out of 100, and so what we did is we took our 3/8 that was a percent and just multiplied that denominator by that 100 because it was out of 100, and out of would be part of the denominator to get that 3 out of 800. So that is kind of a quick and easy way to get that percent that's written as a fraction into a fraction form, is just to multiply that denominator by 100 or add 2 zeros to that denominator, and then it's out of percent and into fraction form. And then if we divided 3 by 800, we would get our 0.00375 as well. So now let's take a look at our story problem, which is giving us some information in a chart. So the following chart shows the distribution of employed citizens in the United States in 2007. and it's based on the age ranges given along the horizontal axis. The horizontal, think of horizon, is left to right. And notice we have 16 to 19 as our first category. And the sum as a percent of all of the age groups, we can go ahead and add all of those up, 4 plus 9.6, and so on. But it's showing all of the employed citizens that are ages 16 and older, so it represents everyone. And so it only makes sense that if everyone's represented, it adds up to 100%, which it does. So since the numbers are given in percent, it's asking what is the percent of workers below the age of 45, and so it's including 44 and below. And so that gives us a couple categories to add together. And so if we start with the lowest, we have 4%, and we're adding to it 9.6%, and then 21.6%, and the final category that's below 45 will be 23.5%, and that gives us a total of 58.7%. So over half of the workers between the ages of 16 and up are under 45. And what percent of workers are age 25 and older? Well, there's a couple different ways you can do that. Notice 25 and older are most of the categories, and so there's only 2 categories that aren't. And so the ones that are below that would be 4 plus 9.6 or 13.6. And so we can take the total of 100% and subtract off that answer, or think of it as subtracting off the 4 and subtracting off the 9.6. And that leaves us that 86.4% of the workers are 25 or older. And then it asks about a trend, which is a pattern. What do you notice about the data with relation to age? If you heard that, sorry, that was just my dog running down my steps. So, without getting too technical, what we have is actually a standard shape for data. This is actually called the bell curve, which means that most of the data, most of the information is going to fall in the middle range. And so we can see that a majority of the workers fall between the ages of 25 and 54. So the trend is that the percents increase to the middle and then decrease towards the end. So let's describe the trend as the percents increase to, let's call, middle age, and then decrease again. So again, that's the standard bell-shaped curve that you'll see a lot in statistics. Next question asks us, what is the difference between the largest percent and the smallest percent? Not age groups, but numbers. And so the highest we have is 23.7, and that was our 45 to 54-year-olds. And our lowest is 65 and older with 3.8%. And so the difference there is 19.9%. And then it says, how does the lowest age category compare to the highest? Well, the lowest age is at 4, the highest is at 3.8. And so I would say that they're very close or very similar. And so if we subtract that, there's only a 0.2 or 0.2% difference between them. So that's it for 4.3. Send me any emails with questions you have as you're going through the homework for this section. Otherwise, I'll see you next time.